Hello viewers, welcome to CAE for you. In this video, we will demonstrate the feasibility of building moderate fidelity CFD model to simulate transonic flow around aerofoil. This is particularly targeted as a method during concept selection as a trade-off between detailed accurate model to lightweight faster model. For this simulation, we chose NACA-64A010 airfoil, which is symmetric airfoil. Since we are interested in section properties, we will adopt 2D simulation. Nevertheless, we will compare the CFD results with available test results. For the present case, we will compare the coefficient of pressure. We will include turbulence effect to make the model more generic. To keep the computational cost in control, we will use RANS model. It will be URANS since transient approach has been adopted. To establish consistency, we will choose two cases, one at 0 angle of attack and other at 1 degree angle of attack. The choice is simply based on the available test data. The data is available on the literature that is shown. To make better comparison, we digitize the plots using Engage digitizer. As you see, we could make as best as possible within the available quality of the plot. The coordinates of the aerofoil was obtained from airfoil tool website. Since it is symmetric airfoil, just one half of the coordinate should be sufficient. We will be using FreeCAD as solid modeling tool, so the point data should be prepared in the format readable by FreeCAD. For this example, the .asc format has been used. We could have directly connected the points, but an approximate spline was fitted with the coordinates. Though this can lead to deviation, we feel it is more realistic. Because in some of the literature, the designed airfoil and the measurement from prototypes are different. It is quite reasonable to introduce a small deliberate variation which is random but small. An important consideration is the computational domain itself. There are many shapes to define the computational domain. For example, the D type, O type and so on. We opted the O type just for ease of use. The size consideration of the domain is important because far field zone should be true far field. We restricted the domain due to computational considerations. If your resources allow, then you can extend the domain. To provide more space for wakes, the domain has been offset towards the trailing edge. The dimensions are just for reference, but not actually a standard. Let us move on to meshing. We used Salome platform for meshing. As usual, we also adopted structured grid. The local refinement were indeed made, but not to the extent of respecting any targeted y plus value. Again, this is a scope for improvement, but for the current simulation, we will keep the simple grid that we have created. Interestingly, the simulation indicated the refinement would be advantageous at the body region than at trailing and leading edge, and also coarse mesh can help in smearing the shock waves which is observed in the test data. So we are going to use modest 30,000 cells for this simulation. Before we go further, let us look into the flow field for both cases quickly. Okay, that is an interesting graphics. Let us look at the convergence plot. For 0 degree angle of attack, except CD, other aerodynamic coefficients has reasonably converged. So we expect a reasonable match with test data. In contrast, the solution didn't significantly converge for the same simulation time. The change in angle of attack is just 1 degree. Thanks to Transonics, of course, the model should be run for some more time till the coefficients converge. It is a bit of surprise looking at the result. The shape resemblance is reasonable for 0 angle of attack. There is an offset in the peak pressure location, but that was also observed in the publication for the calculated results too. That is not an excuse, but we expect a larger deviation due to the complexity for the correct calculations. However, the results predicted are a bit more closer than what we expected. The deviations are more apparent at 1 degree angle of attack. The attributants are so apparent, which we highlighted throughout. The solution which we have seen correspond to just around 6 core minutes time. By all the standards, it is a very quick simulation. However, it needs to be seen that there were quite a lot of improvements which can be implemented for better results. This is really encouraging and for sure can be improved for modest increase in computational cost. You can obtain the working files from Gumroad. The details are provided in description, and your support will help us create more such videos. Thank you for watching.